Hello Madam Rosnani, my name is Fashion Jora of Ramasamy, and in this video I'm going to present about the transfer function. So the transfer function by definition in a circuit of a cause is the frequency dependent ratio. So it does depend on the frequency. It has to do with the signal on an input signal and an output signal, and the amount of the output signal relative to the input signal is dependent on the frequency. It will be different for different frequencies. It will give you a ratio, the output versus the input, and here's an example that the output voltage has dependence on the frequency divided by the input voltage. So that ratio is called a transfer function. The symbol of transfer function is a simple h, and of course it's dependent on the frequency omega. So imagine we have a linear network, we have some input voltage, some input current, we have output voltage and output current, and something happens in the linear network that only allows certain frequencies to get through easily and others not. Transfer function is that function that determines for what frequency it allows the voltage to go through and the current to go through, and what frequency it does not. Transfer function depends on some of concern, which is voltage gain, current gain, transfer impedance, and also transfer admittance. So these are the transfer function depends on it. And yeah, I hope this video is quite long, and my part is actually a short introduction for transfer function. I hope you guys have understand what is the transfer function, and that's all for today. That's all from me, and thank you.
Hello, my name is Yunli Bima Osali, and for my part, I will do the conversion of transfer function to dot plot. The question is given is the transfer function is SW 5 JW plus 2 over JW and JW plus 10. From that, we can rewrite the transfer function into 5 times 2, 1 plus JW over 2, and over 10 JW, 1 plus JW over 10, in which we can simplify and we get the final equation, which is this, FW equal 1 plus JW over 2 over JW 1 plus JW over 10. From that, we can identify each part. For example, 1 plus JW2 is a simple 0. JW is a polar region, and 1 plus J10, 1 plus JW over 10 is a simple pole. From that, we can get the magnitude. This is the equation, and we get this 20 log 10, 1 plus JW over 2 minus 20 log 10 JW minus 20 log 10, 1 plus JW over 10. Notice that I write is negative. This is because this JW and 1 plus JW10 is at the denominator area, so it must be minus. From that, we can draw the magnitude graph. As you can see, this is the dot plot for the magnitude. I prepared this earlier. For the magnitude of 20 log 1 plus JW over 2, you can see that the diameter is 2. This means we have to start at 2. Since this is a simple 0. For that, I will choose a line to the side of 2 in the color blue. Starting from 0.1, I'll stretch until 2. And from there, if you go to the next decade, which is 20. An increase of 20 decibel. Yeah. And next, we have the magnitude for the JW. Since it is a pole at origin, this means it will go down. So starting, I will use the color yellow. Starting from this 20, passing 1, until the next decade, which is 10. Next, I will do the magnitude for the 20 log 1 plus derivative over 10. As usual, it is a simple pole. This means we start at 10. For that, I will use the color blue. Starting from here until 10. I will move this up a bit. I'm sorry, I will use the color green. And from there, it will go down in a negative 20, of a negative 20 until the next bracket is 100. Up to here. So this is the repetitive graph for each magnitude. Now we will get the final answer, which is the resultant of each graph. For that, I will pass the red shape of the line, and then I use the thicker one. From here, from 0.1 to 1, it's just decreasing until it reaches 2. Then we intersect with these two parts. So from here, on 20, draw a line until it reaches 2. Here. From here, this is a plus 20 and a negative 20. This means we cancel out. So it will be until 10. A straight line. Okay. And then from then we go down, we open negative 20 to negative 20. For that, I can do this. And then I will move this line to the other, to the other point. And this is the resultant of the final graph for the dot plot in case of the magnitude of the twist transfer function. This is the final answer in which I have drawn in the dot plot for the magnitude. The final answer represents this red line. After that, we can calculate space. This is the general formula for simple pole slash 0, which is space equal to tan negative 1 W over Z1. As you can see here, for 0 degrees, Z1 is 2, 45 degrees, Z1 over 10 is equal to 0.2, which is starting point. And for 90 degrees, is 10 Z1, which is 20. For 20 log, then 1 plus derivative 10 over 10, 0 degrees is Z1 equal 10. 45 degrees is 1, which is starting point. 90 degrees is 100. For JW, the angle will be a constant of negative 90. From that, we can draw the phase of the transfer function in the box plot. For now, I will draw the graph for the space. Here is the scale that I prepared earlier. For the first one, I will use the color green, which is 1 plus derivative over 2. If we start at 0.2, from there, we'll pass with 2 until 20 at the 90 degrees. And then it will continue as a straight line until 100. Next, I'll read over the JW. Since it is just JW, it will be a constant straight line. In this case, it's negative since it's in the denominator area. So straight line till 100. Might not able to see it. I will choose a darker color. Then for 1 plus dB over 10, you start at 1. For that, I will use the color yellow, color 1, and we'll go down since in the negative area, change in negative. So we go down until it reaches 100. Like that. And now we can do the result, the final product of this graph. From here, it will be a straight line until 0.2. And then it will reach this part 1 because it's addition. It will increase until 1 of 90 degree. And from here, since it is plus 90 and this minus 90, it will continue a straight line until this 20 decade. So we just draw it from here until 1. And from there, since it is 90 and this negative 90, you cancel out, and we left with this, the decrease in this line. So we draw here to here. And then it will go straight. Can make the line thicker for the change. So this red line is our final product of the graph. Based on the previously drawn graph, we can get the final answer for the phase in both plot, which is represented by this red line. Thank you. This is for all from my part, and I'll pass it on to the next person.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Raihana binti Abdul Halim. I'm from 1BEI S1/2. Okay, today I'm going to present about my advanced electrical circuit assignment. Okay, first of all, good morning to my lecturer and my beloved friends. This is my question 3. From the board plot, obtain the transfer function corresponds to it. So, me and my team members have done this assignment. So I will explain this part, particularly this part, the equation of my group members, and we're going to explain about H omega equals to 5 bracket J omega plus 2 divided by J omega bracket J omega plus 10. You can see here clearly. So there are 4 parts that I've already separated from the graph that my friend already draw in the semi-log graph previously. He's already explained. So first one is constant K that we derive as K. Second is simple 0. Third is simple pole. And fourth is quadratic pole. Finally, I've already combined all the equations into one equation. Okay, so the next we will see the derivation for each explanation. Okay, I will proceed to the first one for the constant. HDB equals to 20 log 10. The constant is variable K. So to determine the gain, when the board plot graph starts with a straight line which is parallel to the x-axis, where you can refer to the graph previously my team member has explained in the semi-log graph paper. So which is parallel, that we can conclude that it's from the gain K. Resultant line starts at 20 dB. So where 20 log 10K is equals to 20 dB. This equivalent to 20 dB. So for the second one, proceed to the simple 0. You can see here. So for simple 0, here's the calculation method that I've already written. So the answer is H omega equals to 1 plus J omega over 10. So the explanation, when the resultant line increases, we can conclude that it is a simple 0 increases to 20 dB. The graph goes up, so it shows that it increases the plot. So where the simple 0 results will be 1 plus J omega over Z, where Z is equals to 10 radian per second. Okay, I'll proceed to the next third step for simple pole in the graph. Okay, so this is the calculation that I've already written. HDB equals to 20 log 10. So 1 over 1 plus j omega divided by P1. P1 is pole. For simple pole, so my answer 1 over bracket 1 plus j omega over 100. So for this explanation that you can see over here, based on the bot plot graph, the resultant line becomes parallel to the x-axis at 100 radian seconds. Okay, where before this it was increasing. So before this, you can see at simple 0, right? The graph increases. So we continue from there. This is the third one, third line. Continuing, and hence it's a simple pole, whereas this the equation that just now I've already conclude 1 plus 1 divided by bracket 1 plus j omega divided by P1, where P1 is 100 radian seconds, increased by 10. Okay, I'll proceed to the last step, that is fourth for quadratic pole. As you can see here, this is my calculation that I've already written. So HDB equals to 20 log 10, 1 over 1 bracket 1 plus j omega over P. So this is the answer. 1 divided by bracket 1 plus j omega over 1000, increased by 10. So finally for my explanation, the last resultant line, we can see the line is gradually decreasing 20 dB. Hence, we can conclude that it is a simple pole with a power of 1. Okay, the equation that I've already concluded just now. 1 divided by bracket 1 plus j omega over P, where P is 1000 radian per second. So the graph increased by each and every bot plot increased by 10. Okay, so finally we can see the combination of equation 1, 2, 3, 4 from the bot plot. So we multiply all the following answer till become one equation. This is the calculation steps that I've already written clearly. So h omega equals to 10 bracket 1 omega plus j omega over 10. Divide by bracket 1 plus j omega over 100 times bracket 1 plus j omega over 1000. Equals to, final answer is 10,000 bracket 10 plus j omega divided by 100 plus j omega times bracket 1000 plus j omega. So from here I can conclude that my team members and I do this number 3 question. The graph increasing for this transfer function equation, for every equation increased by 10. So you can see here for simple 0, simple pole, this one, quadratic pole, every equation increases by 10 radius per second. Okay. I hope you all understand the equation that I've explained. Thank you very much. Assalamualaikum.
Hello, my name is Mete Kip, and in this video I'm going to discuss about discussion and conclusion. For discussion, transfer function to bot plot. First, we need to simplify the transfer function. If the transfer function is given in a complex form, such as a ratio of polynomials, simplify it to a standard form using technique like factorization or partial fraction decomposition. Write the transfer function in terms of frequency. Replace the complex variables x in a transfer function with j omega, where j is the imaginary unit and omega represent the frequency. Separate the transfer function into magnitude and phase components. Express the transfer function in polar forms, separating the magnitude and phase components. Convert the magnitude component to a logarithm scale. Plot the magnitude component of the transfer function on a logarithm scale, typically in decibels. This allows for a clearer representation of the system gain across wide range of frequencies. Plot the phase component. Plot the phase component of the transfer function in degrees or radians. This illustrates the phase shift introduced by the system as a function of frequencies. Next, generate the bot plot by combining the magnitude and phase plots on separate graph, typically with the frequencies on a logarithm scale along the x-axis. The magnitude plot is displayed on the top graph and the phase plot is displayed on the bottom graph. Next, about bot plot to transfer function. Converting a bot plot to a transfer function involves the reverse process of creating a bot plot. First, we analyze the magnitude plot. Start by examining the magnitude plot of the bot diagram. Identify the frequency at which the magnitude begins to deviate from its low frequency value. Next, determine the slope. Determine the slope of the magnitude plot beyond the corner frequency. The slope is usually expressed in decibels per octave or decibel per decade. An octave represents a doubling of frequencies, while a decade represents a tenfold increase in frequency. Convert the slope to a polynomial form. The slope of the magnitude plot corresponds to the power of frequency variable in the transfer function denominator polynomial. Each slope of negative 20 dB corresponds to a first-order factor of j omega plus a, where omega is the frequency variable and a is a constant. Identify the magnitude intercept. Determine the magnitude at key frequency, such as the corner frequency or other significant point. This magnitude corresponds to the gain of the transfer function evaluated at those frequencies. Convert the magnitude intercept to a polynomial form. The magnitude at specific frequency corresponds to the gain of the transfer function evaluated at those frequencies. Express this magnitude as a numerator polynomials of the transfer function. Lastly, combine the component. Combine the individual polynomial component obtained from step 3 and 5 to form the complete transfer function. In summary, working with bot plots and transfer function help us understand how a system responds to different frequencies. Bot plots provide a visual representation of a system frequency response, while transfer function offer mathematical models. Converting between the two allow us to analyze and design system effectively. These tools are crucial for engineers and researchers working on a control system, filters, and electronic circuit, enabling them to optimize performance and achieve desired frequency response characteristics. And that's all from my part. Thank you.